All right, so we're going to do part D, solving polynomial equations using sum and difference of two cubes. So the key thing to remember that we've learned is that when you're solving a polynomial, the number of real and imaginary solutions should equal the degree of the polynomial, okay? So steps to solve. 1, we're going to move all terms to one side so that the equation equals 0. 2, we're going to add, subtract, and multiply to combine like terms and write in standard form. 3, we're going to use the sum and difference of two cubes rules to factor. And then 4, we're going to use zero property in the quadratic formula to solve for the solutions. So here's our first problem. 27x cubed equals 343. And so step 1 tells us to subtract 343. So we're going to subtract 343, and that gives us 27x cubed minus 343 equals 0. Step 2 is make sure that you combine like terms and are in standard form. Check, we are. Step 3 is you're going to use either sum or difference of cubes to factor. And this is going to be a difference situation. So since it's difference, that's our a minus b times a squared plus a times b plus b squared. Okay. For this particular problem, our a equals the cube root of 27x cubed, which equals 3x, and our b equals the cube root of 343, which equals 7. So we're going to plug the a and b in where they go. So our factor that we have here is going to be 3x minus 7 times 3x squared is going to give us 9x squared plus a times b, which is 3x times 7, 21x, plus b squared, so 7 squared is 49, equals 0. So these are our factors. Now this isn't our answer because we haven't solved for what x is. So we're going to go on to step 4. Step 4, it says to solve for our answer, we're going to use a zero property, which means we're setting each factor equal to 0, and then we're using the quadratic formula. So we have 3x minus 7 equals 0. So we add 7, and that gives us 3x equals 7. Divide by 3. So we know that x equals 7/3 is one of our solutions, okay? And it's a real solution. So we have one of our solutions. Then we're going to use the quadratic formula to find our other one. For the quadratic formula, our a is 9, our b is 21, and our c is 49. So we have x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, because our numbers are so large, we're going to go ahead and use a calculator to help us. So in our calculator, we're going to input what's underneath our radical. So we have 21 squared minus 4 times 9 times 49. And that gives us negative 1323. So we have x equals negative 21 plus or minus the square root of negative 1323 divided by 18. Now 1323 can be factored down. So we're going to factor 1323. I'm going to use the calculator to factor 1323. So when I look at 1323, I can see that it is divisible by 9. How do I know it's divisible by 9? Because if I add up the values of the digits, it equals 9. And if the digits add up to equal a multiple of 9, then it's going to be divisible by 9. So we have 1323 divided by 9. And that leaves me with 147. So if you're thinking about this in terms of like your factor tree, so you would have 1323, and we have 9 and 147. I would leave 9 alone because 9 is a perfect square, so that helps me in my situation. Now 147, I'm going to look at 147, and I'm going to think about, okay, what things what can 147 be divided by? And it ends in a 7, not many multiples ends in 7. But I'm going to see if it's divisible by 7, and it is. So this becomes 7 and 21, and 21 becomes 7 and 3. And if you're going to use the tree, then great. So this is going to become 3 and 3. So remember, when you are taking the square root of something, you're looking for pairs. So I have a pair of 3s and I have a pair of 7s. So this can break down to become, so when I simplify this, I'm left with x equals negative 21 plus or minus 3 times 7 times I, because it being negative, and then I had a 3 that was not grouped, all over 18. So that's x equals negative 21 plus or minus 21I square root of 3 over 18. Now this answer is right, but however, it's not simplified. So I can divide each one of these by 3. So that leaves me with x equals negative 7 plus or minus 7I square root of 3 over 6. So my two imaginary numbers. So those are my two imaginaries. And remember, the plus or minus means that there's one of each. All right, so if you can do this, then you can do anything. It ties together a lot of things that we've already learned and have been building on. Example 2. So on example 2, we're going to go through the steps. So it says move all terms to one side. So step 1, I'm going to subtract 8 times x plus 1. So that gives me x times x squared plus 8 minus 8 times x plus 1 equals 0. Step 2 says to multiply, add, subtract, do whatever you got to do to combine like terms and put in standard form. So I'm going to distribute. So I have x cubed plus 8x minus 8x minus 8 equals 0. Combine like terms, they're going to cancel out, and we're left with x cubed minus 8 equals 0. Okay. Step 3 is you're either going to use sum or difference to simplify. Meant to factor this, so we're going to be using difference because it's subtraction. So we have a minus b times a squared plus a times b. I don't know why I'm writing my plus sign up there. Plus b squared. So I factor this. So for this, my a equals the cube root of x cubed, which is just x, and my b equals the cube root of 8, which is 2. So my factors are x minus 2 times x squared plus 2x plus 4. Okay, step 4 is where I actually get my answer, is where I solve. So step 4, I take each factor using the 0 property, set it equal to 0. So x minus 2 equals 0. So I know x equals 2 is a real solution. There's my real. And then I'm going to use the quadratic formula. So for the quadratic formula, a is 1, b is 2, and c is 4. So we have x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So that gives me x equals negative 2 plus or minus the square root of 4 minus 16 divided by 2, which equals negative 2 plus or minus the square root of negative 12 divided by 2. We've done this before. Negative 12, if you're going to think about it, it can be factored as 4 and 3. I can take the square root of 4, but can't take the square root of 3. So this leaves us with x equals negative 2 plus or minus 2i square root of 3 divided by 2. Almost done. Outside terms are divisible by 2, divisible by 2, divisible by 2. And that leaves us with -1 plus or minus I square root of 3 as our solution. Remember, this means that I have -1 plus I square root of 3 for x equals, and I have x equals -1 minus I square root of 3. Those are my two imaginary solutions. And that concludes our last example.